guys, and welcome to lesson 8E. I can use trigonometry to find missing values in a polygon and use these values to find the area of a polygon. So sometimes when you come across an area of a polygon formula or problem, you won't have everything you need to find the area immediately, and you will have to use trigonometry in order to help you find the rest of the things you need to find the area of that object. So just as a quick reminder, you have three major segments in a polygon. You've got the apothem, which is drawn from the center of the polygon to the opposite side at a right angle. You've got the radius, which is drawn from the center to a vertex, and you've also got your side length, which I'm going to call S, okay? And as a reminder, we can find the angle measure of one regular polygon using the formula n minus 2 times 180 divided by n. This can be used along with trigonometry to find any missing measurement, a side length, apothem, radius that we may need. You don't actually need a radius to find the area of a polygon, but if you're given that measurement, you can use the radius then to find your side lengths and your apothems. So there are three basic steps to finding the area of a polygon. The first is you're going to create a right triangle with your diagram to find an angle measure, the interior angle of a regular polygon. So that right triangle you're always going to build is like this. It's going to go from the center, down the apothem, down the radius, and half of the side length. This is the right triangle you're going to build. And as you're doing that, you're then going to use your interior angle of a polygon to find this angle here, but then you're going to half it to get this angle here, which will be your reference angle when we do trig here in a second. The apothem or the side length or both will be unknown. You might have a special right triangle. It might be a 30, 60, 90. It might be a 45, 45, 90. If you have a 30, 60, 90, use your special right triangle ratios to find the apothem, side length, and the perimeter of the figure. If not, you're going to use trigonometry to find the apothem and the side length, then the perimeter of the figure. Then you plug into the formula, area equals perimeter times apothem over 2. So let's do some examples. So here's my first guy here. This guy is a hexagon. I'm given that this is the apothem, and I want to build a right triangle here. Because remember, for area equals perimeter times apothem over 2, I need the side lengths and I need the apothem. Well, I've got the apothem, so what I'm missing is the side length. So I'm going to start off by finding this angle measurement right here. N minus 2 times 180 over n, which gets me 6 minus 2 times 180 over 6, which I can tell you right now is going to be 120 degrees. So this measurement here is 120 degrees, which means that this guy here is half of that. This is 60 degrees. So what I've actually built here, if that's 60 degrees, I'm going to redraw it down here. This is a special right triangle where this angle is 60, this is 90, this is 4 root 3. Well, let's label these with our special right triangle ratios. Across from the 90 is 2n, across from my 30-degree angle is n, and across from the 60 is n square root 3. Well, we just built an equation here. N square root 3 is equal to 4 square root 3. Well, my root 3's will cancel, therefore n is 4. So this piece right here is 4. Well, if this little piece here is 4, then the whole side length here is 4 plus 4, which is 8. And my perimeter is the number of sides times the side length, or 6 times 8, which is 48. So now if I'm looking at area equals PA over 2, I've got a perimeter of 48, I've got an apothem of 4 root 3, which now means I can find an area of 48 times 4 root 3 over 2. And I want to keep this in exact form, guys, so I am not going to multiply by the root 3. I'm going to do 48 times 4 divided by 2. So 48 times 4 divided by 2, which gets me 96. So my answer is 96 root 3 units squared. Okay? So that's one where we had a special right triangle. Now let's look at a different problem. This guy has how many sides? 1, 2, 3, 4, 5, 6, 7. My number of sides here is 7, and I want to build a special right triangle. I'm going to go from the center to the opposite side. Sorry guys, this isn't the best triangle ever, but we're trying. There's that. I know this is half of the side length, so that must be 4. So my side length is 8, which means my perimeter must be 7 times 8 is 56. What I'm missing for area equals PA over 2 is I'm missing my apothem. That's what I have to find. Well, in order to find my apothem, I'm going to need to do some trig, which means I need an angle measurement. So I'm going to do n minus 2 times 180 over n, which is 7 minus 2 times 180 divided by 7, or 5 times 180 divided by 7. This is going to get me an ugly number, friends. 5 times 180 divided by 7, 900 over 7, or if we're interested, 128.571 degrees. So, oh, and what I really want is half of that value. So if we then do divided by 2, it's really 64.2857. I'm going to store that value in my calculator so I can use the exact number, but it's basically 64.3 degrees for the purposes of my work right here. And I want to find the apothem. So now I've got a lovely right triangle here that I can solve. This is my area, my angle of interest. This guy here is my opposite side. This is the hypotenuse, which I don't have, which means this is my adjacent side. I'm looking for an opposite. I have an adjacent, which means I'm going to use a tangent function to find A. So I can say that the tangent of 64.3 degrees is equal to my opposite side, which is the apothem, divided by the adjacent side, which is 4. So I multiply both sides of this by 4 to cancel the 4's. So my apothem is 4 times the tangent of 64.3 degrees, which we can find now. So remember how I said I'm going to keep that value stored in my calculator? If I do 4 times the tangent, tangent of, if I arrow up and highlight the number here and hit enter, it'll drop the whole number down into my problem without rounding it. That will get me a more exact value and not a rounded value if I keep it stored in the calculator. And then I hit enter, I get 8.306 for my apothem. So 8.306. I'm still keeping that stored in the calculator because for my perimeter times apothem, I can do 56 times 8.306, all divided by 2, which I'm now going to do in the calculator. 56 times, again, go up, highlight, hit enter, it drops it down, then divide by 2. That's pretty perfect. I get 232.57 units squared. 232.57 units squared. That's my answer. All right, let's keep going. Find the area of a square with a diagonal length of 12. Well, first things first, let's draw us a square. I want you guys to sketch one on your page. I'm going to draw one on my page with my handy dandy clip art tools. Okay, so here's my square. And I have a square with my diagonal length of 12. So if this is the diagonal, this is 12, which means if we really are just going from here to here, this would be 6 because it's half of it, right? Now, a square is also a regular polygon. So we can actually use the regular polygon formula to find the area of a square. I mean, there are actually 3 ways to find the area of a square, but today we're going to focus on exercising that regular polygon muscle because it's a different one for us and one that I want us to practice. So remember that the area of a polygon is equal to perimeter times apothem divided by 2, where perimeter is the number of sides times the side length. So you need number of sides, you need side length, and you need the apothem. So side length and apothem. The only thing you've got right now is number of sides is 4, okay? So I need to find the apothem, and I need to find the side length. I'm going to call the side length S. I'm going to call this piece right here, which is half the side length, X. Okay? That's half the side length. And in order to do this with this particular formula, I need to figure out what X happens to be. So I'm going to figure out what this angle right here is. Well, if this is a square, we know that's 90. This is half of that, so it's 45 degrees, which means this, my friends, is a right triangle, which I'm going to draw bigger. It's a special right triangle, a 45, 45, 90 right triangle. 45 degrees, this is X, this is A, this is 6. If we recall, our right triangles have the relationship in root 2, where this is in, this is in root 2. Guys, this is a different in the number of sides, let's be very clear. We create a formula right here, 6 equals in square root 2. So if 6 equals in square root 2, I divide both sides by root 2. So now I have 6 over root 2 is equal to in. Well, we need to rationalize that, times root 2 over root 2. So this becomes 6 root 2 over 2, or 3 root 2 is your in, which means this guy is 3 root 2, and your apothem is also 3 root 2. So my apothem is 3 root 2, and my side length, which we discussed is 2 times that x value, where 2 times that x value is going to make this 6 root 2. So plugging into my formula, my perimeter, number of sides times side length, 4 times 6 root 2 is in fact 24 root 2. So I get 24 root 2 times my apothem of 3 root 2, all divided by 2. Lots of clever things happen. Root 2 times root 2, I have 24 times 3 times root 2 times root 2 is 2 over 2. Those cancel. 24 times 3 is 72. So guys, that is your answer, 72 units squared. Okay. All right, moving right along. Find the area of an equilateral triangle whose side lengths are 6. Okay, so we've got 2 more questions here, friends. Again, I am going to draw a picture for this because we don't have one. I'm going to throw in an equilateral triangle, and I know my side lengths are 6. So this guy is 6. Well, if I draw in the special right triangle we've been using to do these problems, which I'm going to do again here, that would make this piece here 3. Now, things we know about equilateral triangles. We know that all the angles in equilateral triangle are 60 degrees, right? Which means this angle right here must be 30 degrees, which makes this little triangle right here a 30, 60, 90 triangle. That's one of our special right triangles. I'm going to draw it bigger up here so we can play with it a little bit better, where the thing I'm missing right now is my apothem, right? Missing the apothem. I've got 60 degrees here, 30 degrees here, this is 3, and we're going to label this with our side ratios. Across from 30 degrees is in, across from 90 degrees is 2n, and across from 60 degrees is in square root 3, which means I have the equation that I have to solve. 3 equals in root 3. I'm going to divide both sides by root 3. And then I have to rationalize that. 3 over root 3, I'm going to multiply by root 3 over root 3 to rationalize. So I get 3 root 3 over 3. Well, those cancel. So I get that root 3 is the value of in. Well, that happens to be the apothem, right? So when I'm thinking about area equals PA over 2, perimeter is number of sides times side length, which is going to be 3 times 6, which is 18. So my area is 18 times root 3 over 2. The 18 and the 2 cancel to get me an answer of 9 root 3 units squared. So that's how we can do these with a special right triangle without ever having to touch the calculator. This guy, we're not going to be quite so lucky. There's going to be a lot of work on this one. This is a pentagon. And again, I'm going to draw in my triangle like I always do. And the only thing I have right now is the radius. The radius is 4.3, which means when I'm thinking about area equals PA over 2, I need everything. Perimeter is number of sides times side length. Well, number of sides is 5. Side length is who knows, okay? And my apothem is also missing. So I've got to find my sides and my apothem, which means we have a lot of work ahead of us. Now, in order to do this, I'm going to use this nice little triangle right here. I need to find this angle right here in order to complete this trig. So I'm going to do n minus 2 times 180 over n to get this angle here, or this becomes 5 minus 2 times 180 over 5. And I can tell you right now that this is 108 by virtue of the fact that I've done this 1,000 times. But if you want to plug in the calculator, you find that that is also 108, which means half of it, which would go right here, is 54 degrees. Now, if this is the side length here, I'm going to call this piece here x, where 2 x's equal my side length, and this is my apothem. So let's draw this triangle significantly larger so we can play with it a little bit better. When I'm looking at this here, I'm looking for my apothem, I'm looking for my x. I have a radius of 4.3, and I know that this angle here is 54 degrees. Now, labeling the sides of the triangle comes next. This is the opposite. This is the hypotenuse, which leaves this guy as the adjacent. Now, you're going to have to do trig twice in order to solve this problem. Once to find the apothem, once to find the x value. I'm going to do the apothem first. My apothem is my opposite. 4.3 is my hypotenuse. So that's going to be a sine function. So I'm going to do sine of 54 equals my opposite over hypotenuse, which is 4.3. To solve this, I multiply both sides by 4.3, so I get 4.3 times the sine of 54 is equal to my apothem, which when I plug into my calculator, 4.3 times the sine of 54 gets me 3.47877. I'm going to keep this number stored in the calculator. So that's really we're going to call it 3.5 for right now, is roughly the apothem. 3.5. Now let's find the x value. So the x value, I've got an adjacent and a hypotenuse, so I'm going to use cosine. So I'm going to say cosine of 54 is equal to x over 4.3. Well, multiply both sides by 4.3, so I get 4.3 times the cosine of 54 is equal to x. So I do that in the calculator. 4.3 times the cosine of 54, which gets me 2.52748. Keep it stored in the calculator. So we get 2.5 is roughly the value of x, which means 2x is equal to my side length. Well, let me just do that in the calculator right now. I want to do this value times 2. So I get roughly 5.005, roughly. Again, we're keeping it stored. 5.05, that's my side length, 5.05, which means my perimeter should be 5 times roughly 5.05, which when I plug it in, again, I want to pull this value, keep it stored, times 5 gets me 25.2748. So I get 25.27 roughly. And so now I plug in to my area formula. Area equals that 25.2748 times my apothem, which was roughly 3.5, divided by 2. I have both of these numbers stored in the calculator. So I'm going to jump back to the calculator, wherever it might be. I'm going to pull this value, which is my perimeter. I'm going to come up here. This value was my apothem. Divide both by 2, and I get 43.963 as my area. Area equals 43.963 units squared. And you guys hopefully can really see why you want to be using these TI Inspire calculators to do these problems, because they store values for you and you don't end up rounding, you don't make sign errors or rounding errors. All right, guys, that's the end. This is an on-paper knowledge check, but I believe there is also some practice on MML. This is one of those topics that I think you cannot get enough practice with. It's very important. You'll need to use it for your final project. If you guys have any questions, please feel free to ask. Thank you so much.